We're asked to use the substitution x equals root 3 tan u to show that this integral is as shown. Now this is pretty standard A-level fare, to be honest. It's like dealing with this kind of substitution. You should have seen it before, so I'm hoping it was okay. But I'm going to go through it, of course. So what we can do is find dx by du, which is going to be root 3 sec squared u. And then I can sub in for x, so I'll get the integral of 1 over 3 plus 3 tan squared u, and then replace dx by du du. And this here is root 3 sec squared u. Alternatively, it'd be okay timesing through by du and then subbing in. That will get me root 3 sec squared u over 3 times 1 plus tan squared u du. But remember, sine squared plus cos squared is 1. If you divide through by cos squared, we get tan squared plus 1 is sec squared. So actually these just cancel out, and we're left with the integral of 1 over root 3. You could leave it as 3 over root 3, sorry, root 3 over 3, but in the answers it asks for just like a single constant, and I don't know, I left it as 1 over root 3 anyway. So then I'm going to get 1 over root 3 u plus c. It's got to get u back in terms of x, so it will be tan u is x over root 3, so u is arctan or inverse tan. They have written it as arctan. I'll write it as inverse tan here, but in the answer I'll write it as arctan. So arctan of x over root 3. Or in fact, I think it was px, so let me write it as 1 over root 3 x. Right, first part completed. Now that really was just a warm-up for what is an incredible integration question. So good. We're asked to use this substitution to find this integral, the exact value of I, and it does say in the simplest form as well. Okay, well, it's going to be a similar process to start with. I'm going to find out what dx by du is. It's just this time I've got to use the quotient rule. So I'm going to differentiate the top, giving me 3, and times it by the bottom. I'm using u dash v minus u v dash, I'm just doing it kind of in my head. And then it'll be minus u, the top bit, times v dash, which is just 1. So I'll be minusing 3u plus 3. And it'll be all over u minus 3 all squared. That gives me 3u minus 9 minus 3u minus 3, which is minus 12 over u minus 3 all squared. Okay, brilliant. What I'm then going to do, I'm just going to kind of park that over here, is I want to be subbing in for x in a minute. So, but rather than just subbing it all straight in, let me do it in stages. Let's work out what 3 minus x is. So it's going to be 3 minus 3u plus 3 over u minus 3. So I'm going to straight away put it over a common denominator. So I'll get 3u minus 9 over u minus 3 minus 3u plus 3 over u minus 3. And actually, again, that will give me a minus 12 because I'm doing 3u minus 3u, and then I'm doing minus 9 minus 3. So minus 12 over u minus 3. And then let's sort out 3 plus x squared. So that would be 3 plus 3u plus 3 squared over u minus 3 squared. Then I'll get 3 lots of u minus 3 all squared plus 3u plus 3 all squared all over u minus 3 squared. It's got to cancel this down now. So 3u squared minus 6u plus 9 plus 9u squared. And then I'll get plus 9u plus another 9u, so 18u plus 9. I'm expecting this to cancel down quite well as well. So 3u squared minus 18u plus 27 plus 9u squared plus 18u plus 9. These cancel. Which gives me 12u squared plus 36 over u minus 3 squared. I could even bring a 12 out, give me 12u squared plus 3 over u minus 3 squared. Right, we've pretty much got everything in terms of u. It's not always good to do this because sometimes things cancel out and you didn't have to, but I'm sensing that's not going to happen here. Okay, the only thing I'm going to do is change my limits. So I've got x equals 1, then 3u plus 3 over u minus 3 will equal 1. So 3u plus 3 will equal u minus 3. 2u will equal minus 6. U will equal minus 3. And then x is equal to minus 3 gives 3u plus 3 over u minus 3 equals minus 3. 3u plus 3 equals minus 3u plus 9. 6u equals 6. U is equal to 1 here. Okay, so we've done a lot of groundwork here. We're ready to sub it all in. You could have gone like straight there, but you know, at some point you'd have to kind of do this, and I think it's just good to do it in these 4 little stages. So I've got, oh, let me call it I. Just realized actually that is going to help us later on. There's something that's going to happen. I didn't realize it when I did it. So we've got the integral from 1 to minus 3 of ln 3 minus x over 3 plus x squared dx. These are x limits. What I can do now is get everything in terms of u. So I'll get u equals, remember when x is 1, u is minus 3, so actually it swaps around. And then here is 1. And then ln 3 minus x was this minus 12 over u minus 3. All over 3 plus x squared, which I've figured out in green. 12 u squared plus 3 over u minus 3 squared. And then I can rewrite it as dx by du, or alternatively make dx the subject. And for that, I'm going to get minus 12 over u minus 3 all squared. Is it? Oh, sorry, u minus 3 all squared. Du. Now to cancel this down as much as possible. So I'm just going to make the limits minus 3, 1 now, get rid of those u's. And then it's ln. And I didn't really like the minus when I saw that, so I made it 12 over 3 minus u. Then instead of dividing by this fraction, I can keep change flip u minus 3 squared over 12 u squared plus 3 times minus 12. It's a little bit easier to see now that it will cancel, but you could have just chopped them out like that. But now we can see a bit more easily that it happens. And the 12 and the 12 cancel there. But again, you can see a little bit more easily from here. So this gives minus the integral minus 3, 1 ln 12 over 3 minus u over u squared plus 3. Now, part of this seems like we haven't actually simplified this much. It's not like it's become really nice to integrate. But actually, if you look back at the original question, we are very close to getting exactly the same integral. And that is a good thing, because then we can relate I and I together. You'll see in a second. So the first thing to do is I'm going to swap the limits around. And you can do that. You can just, if you get rid of that negative, it just becomes 1 and minus 3. So the integral of AB equals minus the integral of BA. Because in the first one, we're doing the limit with A in and minusing the limit with B in. In the second one, we're doing the limit of B minus the limit of A, but then we're making it negative. You get the same thing. And then I'm also going to write this as ln 12 minus ln 3 minus u. And then I'm going to write it as two separate integrals. I've got minus the integral from minus 3 to 1 of ln 3 minus u over u squared plus 3. And then I'm going to be adding ln 12, brought the constant out, times the integral 1 minus 3 of 1 over u squared plus 3. Don't forget that is I. Now the thing is that this is virtually identical to this integral. It doesn't matter that it's got a u there, we're still doing a definite integral. But it's not actually I, it's minus I. And so suddenly, this awkward integral I've got rid of by just getting the same thing. And therefore, 2I is equal to ln 12 times this integral that I've got here. But that is the integral that we found in part A. So therefore, I is going to be a half ln 12, and then it's going to be 1 over root 3 arctan 1 over root 3u, evaluated between these limits using A. I can also just bring that 1 over root 3 out to make it a little bit easier. So it'd be 1 over 2 root 3. And then I'll be timesing by, I'm going to write its inverse tan of 1 over root 3 minus inverse tan of minus root 3. Inverse tan of 1 over root 3 is pi over 6. Inverse tan of root 3 is pi over 3, but then it becomes minus pi over 3 here. But then let me do this in stages. So it's going to be minus pi over 3. That's what I'm trying to say, which actually makes it plus. And that will become pi over 6 plus 2 pi over 6, actually pi over 2. Okay, and we're basically there. We can write it as pi ln 12 over 4 root 3. Okay, in the answers, they rationalize the denominator. I didn't do that, but they go with pi root 3 ln 12 over 12. Okay, is that a bit nicer, I guess? All right, that is a fantastic integral. Many places you can make mistakes, but I think what I would advise is like just don't throw x into everything from the beginning in terms of u. I think this like step by step bit here really set me up well for the next parts. I noticed that I could just cancel things down. I'd done that, simplifying. And then at some point you've got to realize, okay, I can swap the limits around and then it's essentially the same integral. Just got to sort out that ln 12 over 3 minus u. Realize that it's I equals minus I plus this integral. Use part A. I mean, it's just so good. And get this answer. Well done.